Hi, everyone. This is KubeVirt community DRA sync up. Today is February 11th, and welcome. I'm going to put the document in the chat if everyone wants to put their name in the attendees. Then we can get started. I'm going to share my screen. Okay, so for today's agenda, I wanted to quickly recap where we were at with the DRA proposal. And then based on that, I wanted to show a small demo. This is implementing the current state of the proposal, and then wanted to open it up for discussion with everyone. That sounds good. We can dive right in. So based on our last discussion last year in October, we were discussing on what the status of the VMI should look like. After a couple of back and forth, I think we agreed on having very succinct fields in the status so that if there are users who are requesting large number of devices, the status field doesn't grow too big. So those fields were things like GPU name, PCI address, or the MDEV UUID. Having them in the status will allow us to have nice interface around which we can design the API. And then the spec fields in the proposal mostly looked okay to everyone. At least I did not hear any major concern around this spec field. So with that background, I'm going to quickly start this demo recording. I'm going to talk over the recording. So and then after the recording, we will open it up for further discussion. Okay, starting now. So in this recording, I have a DRA plugin running. That plugin has already advertised resource via resource slice object. The resource slice object has vGPUs and physical GPUs advertised. This is the example of a physical GPU where you can see the PCI address here. And then these are the example of a vGPU 2:1 type. There are two pGPUs, which means there will be four vGPUs in the system. Now I'm selecting the device class here, and in the device class, you can see that attributes is the one that is selecting the type of GPU. And in the attribute, we have type GPU, which can be correlated on the right on the device, right? So this is a pGPU. And then similarly for the vGPU, we have type equals to vGPU and then class equals to 2:1. Then if you look in the resource slice, you can map the same attributes for a vGPU, and you can see there is a UUID present for this vGPU. So now that you have device classes, user can consume these device classes via resource claim template. So on the left-hand side, you can see a pGPU resource claim template. It has a request for single pGPU and the device class name VFI or PCI. On the right-hand side, you can see a vGPU resource claim template with device class vGPU 2:1 and the request name vGPU. Now, this resource claim template will be used inside of VMI spec, just showing the resource claim templates that were created, pGPU and vGPU test template. Now on the left, we'll be looking at the VMI spec. On the right, VMI spec for vGPU. So looking at the left pGPU spec, we have the resource claim template for pGPU. And that resource claim template is referenced in a resource claim, which is then referenced inside of the GPUs. This is the standard way of doing it in pods as well. And then on the right, same thing with vGPU template. And now we'll be starting these VMI, both pGPU and vGPU ones. On the bottom, you can see the pod and the resource claim that was created for it. As soon as they were created, we saw it got allocated. And now looking at the VMI status, you can see that PCI address inside of device status field and the resource claim name, which corresponds to the resource claim mentioned, you can see here. Similarly, for pGPU device status, you can see the MDEV UUID, the name of the GPU, vGPU 2:1 with an index of 2, and then the resource claim name. So you can see here that from our last iteration, the status was made significantly smaller, just the 2 relevant fields that were needed. And now we are deleting the VMI, so those resources will be reclaimed. Okay, think that's all I had with the demo. I'm going to stop sharing now and share a different screen. Okay, so I think with that, we can open the floor up for questions, feedback, discussion. Ladik, I see you have a hand. Go ahead.
Thanks, Ali. It looks nice. My question is how so the VMI status, how is it being used? Is it just a reporting right now, or do we use it for allocation, or how's this being
Sure.
used?
So the VMI status is available inside of Virt launcher. So it uses the VMI status to create the DOM XML. So instead of using the environment variables, which would be hard in this particular proposal, we use the status to generate the right DOM XML inside of Virt launcher.
So what would happen, for example, on live migration?
So on live migration, I assume that when the pod is deleted from the source, the allocation status will go away because those resource claim will be deleted by the system.
But before the live migration is being initiated, I mean, you would need to create this target domain XML, so you would need to know the definition of the target, like what has been allocated on the target. The question is how you are going to communicate. So if this mechanism, if you're creating domain XML from the VMI status, it will be hard for you to do it on the target. So basically, you would need on the source, as it is today, to have both the current information and what is there or has been allocated on the target. And this is going to be a very difficult mechanism to synchronize.
So in the case of live migration, can you help understand if in live migration, will the source and target word launcher pod coexist for a temporary amount of time, or like how does the end-to-end workflow look like with live migration?
So as it is today, and this may be open for changes in the future, but as it is today, we have the VMI object and the source pod, and then when we want to migrate it, then effectively we gather the content. So we create the target pod. Target pod is being created by the virtual machine migration controller. It's being scheduled on the target, and then on the target word handler will then update the VMI object with what has been with some context on from the target. And then the source will need to generate an XML, basically the target domain XML, and then send it over. So the concern is here is that you will need both the source information and the target information about what has been allocated to the target on the same VMI object, which is a bit tricky. And then how is this getting cleaned up in the future? Now, as it is today with device plugins, this is not necessary because the VMI spec is the same, and there's basically no need to update anything. So the target in the future may know how to manipulate the domain XML without. That's our desire to make it in a way that the target will be able to manipulate the domain XML without the need for the VMI object itself, just based on what has been allocated for the target pod.
I see. So when this synchronization happens, are there any status conditions in the VMI that reflect that this handover is happening between source and target? Because conceptually, what I'm thinking is when the target pod and its resource claim is created, the system will have information about its PCI or MDEV IDs, right? And in the controller that updates the VMI status, we can have a mechanism where it could, during this handover, when the status reflects that the object is now moving towards the target, it can update the status information right there. Do you think that will be challenging to coordinate, or are there fields inside of status that can help us to coordinate this handover?
So there are, but it blows the API kind of.
I see.
Just a sec, let me. Jed, you wanted to say something? I couldn't read that.
Sorry, I didn't get the last part.
You wanted to say something, right?
No, yeah, sure. I just put it in the chat. Yeah, we already have a system, right, for transmitting the information from target pod to the source pod so that we can alter the XML. wouldn't that be able
The
to
idea,
use?
yes, but the idea in the future is to get rid of this and to be able to allow the target to basically generate the target domain XML or modify it. So yeah, so today we can push all of this stuff into the migration state. But first of all, it will increase this object dramatically with all of this information there. And yeah, and then something on the target when the migration is over, we'll have to update the VMI status. So with the current representation.
Yeah. So I think the way we have written the status update part is it is totally independent from the word controller logic. So if you look at this particular design document, there is a section on how the status is gathered, right? So there are 4 steps. One, you have to look at the resource claim status. From there, you have to find the resource slice. And from there, you have to go look at the device in the resource slice to get the exact PCI address or MDEV address. So the way we have currently implemented this is in a totally separate controller within Word controller that just watches on this particular resource claim and resource slice objects, as well as pods, and generates the VMI status for it and patches it in that controller, right? So it is completely separate from the VMI controller. And the good thing about that is we can, for instance, use the same controller to, instead of having this information in the VMI status, also have it in the pod annotation, and then mount that annotation inside of the pod via downward API. If we do that, then we make the source and target independent, as long as we can guarantee that the controller is delivering the right information to the annotation on the target pod. Then we would ideally be able to make live migration work in that scenario. I'm assuming that is how networking currently also works in case of live migration, right?
Network doesn't create SRV devices that way. No, I think it doesn't work that way.
I mean the pod status that is coming from Multus, it gets mounted from the annotation into the target, right?
I don't know. Aurel, do we pass anything from the pod to the VMI?
We do pass some information from the pod to the VMI, especially when discussing SRIOV, and some network binding plugins has this capability. At least it's in the API.
Do we use downwards API for this?
Yes, we do. We fill some annotation. We fill the annotation in the pod, and then it basically transferred into download API and becomes a file in the pod file system.
Yeah, so I think theoretically we can use the same mechanism to deliver these updated information on the target. And in that case, the VMI status will become read-only, and KubeVirt will start acting on the annotation to generate the DOM XML.
By the way, this mechanism is not it's not perfect. Like, we are struggling with it sometimes, especially on migration.
What kind of issues are you seeing with this?
Can give you one example. In the SRIOV case, when we spin up the VM, we take information that Multus provides us from the pod, and then put it in another annotation on the pod, and then it creates the file in the Virt Launcher compute container, and then the Virt Launcher application reads it. But when we're performing a migration, this happens only very late after the migration is already finished, because the migration controller creates the target pod, but the VMI controller is handling the actual transfer or crunching of this information. So it happens very late.
I see.
And just to clarify, we take information from the pod and put it on the pod.
Right. So in our case, what will be happening is we'll take information from Kubernetes APIs that get populated after the pod has been created, and then put it onto the pod annotation. So the same problem where the information is little bit late will apply in this case as well. But in this case, we would have to find a way to block the DOM XML creation, because unless this information is not present, those devices will not be available in the target. So I'm not sure how networking is being blocked or it continues even without this information, but here we definitely have to wait for it to be available.
Because the
But,
network is good.
Now, my question is, what does it mean it won't be available? When the pod is up, it means the devices are hooked up, right? I mean, they should be already present in the pod, which is ready.
That is correct, yes. But there will be latency between that information. So there will be two additional steps introduced, right? One is to look that information up and put it on the annotation. And then the second one where kubelet reads that annotation and creates the downward API file or environment. So because of those two things, there will be latency. And when the pod starts up, it has to wait for that information to be available.
And how long should it wait for it?
I assume this should be happening within like seconds. It should not be that delayed. Unless on the target, there is some kind of an issue where allocation is not happening.
I mean, there could be all kinds of different issues. I mean, the pod, I don't know how can the pod know that it should wait for this?
I think there is a value in Virt Launcher pod which has timeout for VMI not being available, right? We could use the same timeout value. It is configurable right now by users.
No, not on the target. The target at the moment, at the beginning, there is no VMI. Sorry. In the Virt launcher pod, there is no domain. I think this is what you mean, right? A timeout for a domain being available, or a timeout for what?
Yeah, timeout. So there is a flag inside of Virt launcher which controls how long until the domain is available. And if that is not available, then like basically the VMI, this timeout will happen and VMI will go into failed state. Can we continue to use the same flag?
Yes, but
So
the migration, it's not. Yeah, you mean that we will not spawn the migration because the steps for a live migration are different. We first create the target pod, and there's no VMI in there. Sorry, there's no domain in there. The source, libvirt creates the migration, and then it would post a target XML in the target libvirt, and only then there will be a domain present.
I see.
And these timeouts are different, so it doesn't wait for any annotation. This is just, it means that the libvirt is up and it's waiting for commands.
I see.
Also, you said that there is a separate controller that updates that VMI status. Is that right?
Yes. I mean, that controller is part of the Virt controller package. It's just a separate sync loop within the same
Yes.
controller. Yeah.
So when you have two pods, I mean, what during live migration you will have two pods. What this controller will do at that time?
So unfortunately, currently it doesn't do anything. What it ideally should do is identify what is the source and target, and until VMI status doesn't reflect handover is successful, it keeps reporting the source status. When VMI status indicates that the handover is successful, it will reflect the target status. I think that those are the steps I have in mind. Does that work?
I'm not sure. I mean, I don't know. I think this in general was a bit frightening to me. All of this change that we're going to do right now, because it doesn't contain any information about what are we doing during live migration. And since we're changing the way devices are being allocated, then we also must think about all the aspects that will be involved with live migration. So for GPU, we're not going to do live migration right now, but for vGPU, it is a thing, and for other devices that can be migrated. So that support is going to come to KubeVirt soon. So I think we must think about the migration process as part of this proposal as well.
Okay. Yeah, that's great feedback. So I'll be honest, I did not look at that aspect. It was not part of the conversation yet. So I'll spend some time looking into that problem space and come up with some kind of solutions. Also, I'll look at the things we have discussed today about whether we can do something in similar to what networking does in the case of annotation, and see what challenges happen there as well.
Sounds good to me.
So just getting the feel of what we are thinking right now, like if there is a way to synchronize via annotation, would that be reasonable approach? Like some kind of a timeout from the launcher? I think then, we can talk about the specific, but overall direction wise, does that um, kind of work, or do you think that, like we should find better ways of looking at it?
If you ask my opinion, I'm worried about this. It's pretty racy, and I'm not entirely sure what does it mean to wait for this annotation in the current live migration process. Maybe we should use the migration state in the status to synchronize that right now and then get rid of this in the future. I'm not entirely sure, but I think the best way is for you to familiarize yourself with what do we do currently during live migration. Well, for example, with CPU, as Jet suggested, and then
Yeah,
work that way from there.
sure.
All right.
Yes, I just wanted to say that please note that there is a 20 seconds timeout between Virt Handler and Virt Launcher every time you do sync VMI. Maybe in the first time that you do sync VMI and the VM is just starting in the Virt Launcher, it could time out and it breaks our end-to-end tests. So please note it.
Yeah. I mean, if resources are available on the target, I don't anticipate it taking 20 seconds to synchronize this. Only when resources are not available on the target, things could potentially go wrong. But that could happen even in the case of device plugins, right? Where if the GPU is not available on the target, then the pod will continue to be in pending state. Yeah, I think I'll familiarize myself with this problem space and potentially add things to the proposal for handling live migration.
I mean, the live migration itself can be a secondary step, but it must. I mean, when we design this API, we must take it into account that it will eventually be there. I mean, but the implementation itself may come later. But just, I mean, in terms of API design, we need to know how this is going to be handled.
Okay. So one of the things I also remember is the volume status has some kind of differentiation for migration as well. Is that something we could look at for devices?
So with the volumes, it's also a bit tricky because I mean, there are some volumes that are being generated on the source, and these are like generated volumes, ISO files and things like this, that eventually will need to be copied over to the target. So these are the one type of volumes, and then there's another type of volume that is basically can be detached from this. It can be connected to both the source and the target, and then when the migration is over, there's basically a failover. So the source pod dies, and the target volume is just connected to the target. So that's the same. I mean, it's the same volume that's connected to both, and then it's been not handled by libvirt. It's just been kind of skipped. And then there's this third type where there are two volumes, and these volumes are being copied. It's live storage migration.
Mm-hmm.
So I don't see how. So at the moment, I'm not entirely sure how devices can fall under that category. But
No, what I mean to say is, since volumes use the status section to coordinate such migration, can we potentially look at it as an example to also, see if we can design the API to have those provisions in place?
I'm not sure what do we do with volumes
Okay,
during that.
I'll take a look at it. Sure.
Yeah, right. Does anyone else has any other ideas or?
One quick question. So so assume that we have a story for live migration and how to potentially handle it. Are there any other concerns with just running devices in VMIs via this approach? I want to see if there are other things in the design or API that has to be addressed.
I generally don't like the idea that we are synchronizing or creating devices based on the status, based on the VMI status. I would expect, Kubernetes components to just make this available, and we'll just use whatever is in the pod. This is more more natural, I think, like more Kubernetes friendly. But I mean, if there is no other ways, then we need to think of something else. But I mean, in general, I would expect it to be discoverable and not synchronized through the VMI status. I mean, VMI would just need to express what it wants, and then the XML would be crafted based on what Kubernetes allocated. I mean, this is the concept so far, but I mean, I understand that there are all kinds of different complications, and it's not always perfect. So,
yeah, I think so in KubeCon Europe, we were trying to have this conversation with core Kubernetes folks, Tim Hawkins and others who work with API designs all the time. And we wanted to ask them, like, how do higher level workloads, consume these low level information? Would they find it acceptable for KubeVirt to have this in the status section? So I think their thought process was in the following manner. So ideally, they would want to have this information in pod status. It helps people who are writing controllers. But the thing with pod status in Kubernetes is that there are lots and lots of controllers that are watching those APIs. So whenever something has to be added, it goes through a high level of scrutiny inside of pod status, because it adds a lot of things to performance and scale in core Kubernetes. However, since additional components like KubeVirt don't have the same fan out in terms of controllers and watchers as core pod itself, I think their suggestion was that putting it in VMI status might be okay thing to do, since if there would be like 100 controllers watching pod, there would be probably 5 or 10 controllers watching VMIs. And considering those trade-offs, it might be the right thing to do. At least that's the takeaway I got from that whole conversation. So I just wanted to share that with folks here to have some context. Yeah, sorry, Varun, you had your hand raised.
Hey, yeah, I have a comment on the migration that we were talking about earlier. So, for DRA, we would currently create a resource claim object and then link it to our VMI. And that's how Bot Launcher pod would be able to come up. So if you're doing the migration, then we would need to create new resource claim objects that would basically allocate the devices on the target node. And I don't know if it would make sense for these new objects to be part of the same list in the VMI while the migration is happening. So definitely makes sense to be somewhere in the migration status where it's staged while the migration is happening, and then at the end of the migration, then we move it back to the VMI status. At least that's what I was thinking on the note.
Varun, while you're speaking that out loud, I think the other thing we also need to look at is does current DRA implementation support creating a resource claim on specific target node? So I'm assuming what we will require here is that we want the resource claim to be on a specific node, and it has to be allocated via the scheduler. So does current DRA have the provision of creating a resource claim on a node directly?
So that's essentially taken care of through the pod scheduling, right? So once you put a pod spec in the API server, when that pod gets scheduled, that's when the resource claim is created, the devices are allocated. So when you create a resource claim by itself, it's not linked to any device or any node. It's only when a pod tries to use a resource claim or a resource claim template, that's when it gets linked to a node.
Yeah. So essentially, we are using the scheduler constraints to guide this to a node and using the pod spec for it. Okay, makes sense.
Yeah.
Okay. Does anyone have any other thoughts, questions, concerns?
Yeah, I think yeah. Let's figure out the migration part. Be sure that we have a way and pass forward. Then, and if you need help with understanding what's going on right now in migration, then feel free to ping us. And lots of people are involved in this. The problem with this is like really the core, to upgrades and evictions and all kind of things. So we need to figure this out.
Sure. Yeah, we'll look into it, and we'll keep you guys posted.
Perfect.
Olay, what would you say like your? Oh, sorry, Vladik. What would you say your plan? So we've got some feedback here. What do you think? Like we meet again and go over this and one more time, and then maybe if we feel good about it, we can start like getting like moving forward with like this document. Like how, I don't know, what's your sense here?
Yeah, so I think next week, the same time, if we can meet and discuss the live migration story again. I think it will give me time to go through stuff and come with ideas. And once we have that discussion, we can put it on the doc and like the design doc and take it forward from there. Does that help? Like those were my thoughts, Ryan.
Yeah, that's fine. I mean, there's one way to do this. I was just wondering because like let's meet again. Yeah, I think that's a good idea. Let's meet again next week. Let's go through that specific question and how it pertains, how live migration will affect our API. And then, let's see if we all feel good about, we've addressed all of our concerns and, and then we can maybe if we have to, we can move to like some of the finer points and getting this, close to being signed off.
Yeah. Yeah, I think I am hoping to also get some time in the unconference session to discuss all the nitty-gritty details about this. So we could have used those two opportunities to take this forward.
When's the unconference?
Don't know the date top of my head. Does anyone remember?
I thought that this is in 2 weeks, but I need to check. Just a sec.
Okay, so it's nearby. Yeah, I guess what I'm wondering, Ale, is like, let's see, because I feel like what you have here seems really close. When you did the demo, and we can see some of the functionality appearing on the API object, and some of it kind of coming together. And I feel like we kind of even have a sense of how this works. So I wanted to see like how what probably a few more meetings. It seems like getting a few of these things settled down and then, maybe we can, well, it seems like we're close to sign off, is what I'm trying to say, after a few more meetings.
Yeah. Yeah. So I think next week we can meet again, and then the week after the unconference, that'll give us good time with the feedback on all aspects of this. And then we can take it forward to sign off. Yeah.
Sounds good. And thank you very much, Ali, for the demo. It was very useful to see how everything is working together.
Okay, sure, no problem. I'll try to update the document with the recording link so that we have a reference for future. Thanks, folks, for joining. We'll see you same time next week then.
Perfect.
Thank you.
Thank you.
Sounds good. Thank you, everyone. Bye for now.